All right, physics students, this is your wave interaction lab. I'm gonna do an example and then you can go from there. I'll give you some more ideas as well. So here's my phone, and I know I have the Science Journal app on it. So I'm gonna click that. I'm gonna do a new experiment, and I need a sensor. So I'm gonna use my ambient light sensor, and I can figure out where my sensor is by right there. So this is my ambient light sensor. So if I cover it, can you see how when I block out the light, then it doesn't pick up anything? And when I let it go, there's my ambient light intensity. So this is, the units are LUX, and this is what I'm gonna use to help with my experiment today. So you have your rubric that you've always had, and then I kind of scaffold it, and you can just write it. You don't, you can absolutely type it, or you can write it and take a picture and upload it. So in my explanation, I just write a little bit about what I already know about light waves, because that's what I'm going to be using in this lab. So the light waves are coming down from the ceiling, and it is a type of radiation. Light is a type of radiation, and it's a type of radiation that is being picked up by my phone sensor, so which is nice. So light can be transmitted through some materials and absorbed or reflected from others. So I'm just going to focus on the light being transmitted through different mediums. So to validate that I can do this, if I put a soda can over my sensor, can you see how I get 38 luxes? So obviously light is still hitting the sensor, and the reason why is because of the reflection from my pop can. So my pop can is reflecting down on it. Obviously nothing is being transmitted through my can, so that's interesting. So I could use different materials and kind of infer reflection if I wanted, but in this case I'm just gonna be changing mediums inside of a pop bottle. So for my first data point, so you can see I wrote a question: which mediums allow the most light to transmit through to the sensor, and which transmits the least? So I'm going to use food coloring and liquids and air, and I might even stuff some aluminum foil in there if I feel like it or something. But I'm just gonna use that bottle as like the container of whatever medium I put in it. And I am going to hold my pop bottle like so. So that's kind of the picture I drew in the setup. So you can see the radiation coming down from the lights, hitting the bottle, and it's either gonna be transmitted through or it won't be. So that's what I'm investigating, is how does different mediums inside my bottle affect how much light is being transferred. So right now you can see it's usually 360. That's like my control with just air going through. So what if I change it to be the bottle and whatever I put in the bottle? Okay, so my independent variable is the types of medium inside my bottle. The dependent variable is the light, how many luxes, and then my controls are I'm going to use the same bottle with different mediums, so I'm not going to change the type of bottle. I'm going to use the same surface light from my classroom, right? And of course, everything in this environment is going to be the same, like the temperature and the wind and stuff like that. So we're going to start collecting data. I'm just going to do a few of them, and then we're going to go on. So if I just have an empty bottle with air, so it's just the bottle and air. Okay, so there's air inside. How many luxes are going to be there? So I make sure my thing doesn't go to sleep on me. So it's 200 and 280. So 280. You can see that it's usually around 360-ish. So I did block some light with this. So there was a significant decrease. Now if I do bottle and water, so now I'm changing it to a medium. So this is a gas medium, right? It still has to go through the gas and then the solid parts of the bottle. And now I'm changing it to a liquid medium. So when I have a clear liquid, look at that, it's higher. So what I'm getting is I'm getting some amplification of the light. So my water is acting like a prism. It's increasing it. So it's 351. So I actually had more. So hopefully you guys are gonna, like, even me doing this lab, and you can see where that air bubble is, definitely makes a difference here. You can be surprised by the data. So now is what I'm going to do is I'm going to use some food coloring and put the food coloring in there, and then I'll check back in a minute. All right, so now I'm done collecting the data. You can see I have more than 5 variables, so that's good. And once I've got my data, you're going to graph it out. So in this case, I'm going to do a bar graph. I could have changed this a lot of different ways. So you guys could just change the darkness, so like 1 drop versus 2 drops versus 3 drops of whatever food coloring you wanted to. So you just keep adding drops into the water. And then if you did that one, you would do a line graph instead. But as it is, I was kind of comparing apples and oranges, so I'm going to do a bar graph. And in my analysis, I'm just going to write what I see in the graph as if you were to explain it to a blind person. So black transmitted the least, and the clear liquid transmitted the most. Okay. So on the next page of your lab, you have to do your conclusion. So just to remind everybody, the conclusion is you're going to answer your original question, you're going to identify any problems with the data, and then observations that contributed to learning more about it. So my hypothesis was wrong. The air transmitted less light to the sensor, probably due to some kind of reflection and application of the light inside the water. So, all right, and then to continue on, black light did absorb the most light. So since it absorbed it, it didn't let it transmit through. So letting less light through the medium. So since I've noticed that, and I know that my my bottle situation where the liquid actually transmitted more light than the clear, so I checked that. So this is adding to like what I've learned. So I put on a empty cup, so that's about 320, and then a cup full of water, and that's about 360. So I know, and then normally it's like 375. So I know that water is doing something. It's bouncing extra light around inside and transmitting more. So to make it more fair, I could probably have used a cup like this. Maybe it would make it more fair, or a square container, something that wasn't round and bounced light a little less. And then I noticed that the yellow light let more light through than the blue, red, or green, which I thought was interesting. And then, why were you interested in this application, and what does it have to do with the real world? Well, I'm interested in building a greenhouse, and I noticed in the greenhouse plans that they would put pop bottles filled with water in the back of the greenhouse, so the south-facing light would come right through and it would warm up these pop bottles. So there was a lot of information about what kind, if you should color the water, or if you should just use darker bottles, or use black PVC. So that's why I was interested. This kind of validates that black absorbs the most heat, and so you should use that in the back of your greenhouse. All right.